Good morning. I'm Richard Burning with Lake Mills Fire Department, and we're going to go over basic pump operations. Our objective is to identify two types of pumps, identify at least two different types of pumper apparatus, and understand how to use the pump and get water from the source to the fire, to the target. We'll be able to operate the pumps with the basic knowledge and understanding of how water gets from the hydrant to the fire. You got two different types of pumps. You got positive displacement pumps, and here are some examples. You got piston pumps, rotary pumps, and different types of rotary pumps. You've got centrifugal pumps. They come in single stage and multi-stage. You've got different types of pumper apparatus. You've got engine pump, also known as pumpers. They are also the main fire apparatus. You've got tenders, which carry water from the source to the fire. Mini pumpers are kind of like pickup trucks. They're a smaller version of an engine. Aerials, and you got quints, which are engines and aerials combined. Wildland apparatus are pickup trucks with water tanks to go out into the woods and put fires out in the wild there. Engine pumpers, the primary fire attack apparatus. Everything is on them for attacking fires, doing medical calls, or going to traffic accidents. Your SOPs or local practices may dictate what has what on specific trucks. The minimum pump capacity for a pump on an engine is 750 gallons per minute according to NFPA 1901. It can go from 750 to 2,000. It depends on what the need is for that apparatus. Wildland apparatus, they are usually a unit that goes into the woods and fights fire off the road in the woods. They are, just like I said, they're pickup trucks. They have a small pump on the back or on the front, depends on what the jurisdiction wants. They have to be at least 500 gallon per minute pumps and be able to roll and have independent ability from pumping and driving. Quints are aerial apparatus with pumps. They have everything needed to be an aerial apparatus, which is a full complement of ground ladders, a aerial ladder, and hose, or that's aerial. They also have everything to be an engine. They have hose, water tank, and a pump. NFPA 1901 requires that their capacity be at least 250 gallons per minute at 150 psi. To be a true quint, the pump shall be at least 750 gallons a minute to equal that of a pumper. The unit provides flexibility if you're on the fire and you need an engine or you need a ladder truck and you only have minimal resources. You get 2 in 1. But you got to keep in mind that when you use this truck and you go to a fire as an engine, you park it where you park your aerial in case you need the aerial. Aerial apparatuses are just like what they say, they're apparatus with ground ladders, an aerial, and they have other specialized equipment that can be used for ventilation or extrication. They don't have the pump. They, according to SOP, they could have any specific special utility. They don't have pumps, like I said. They have pre-plumbed waterways that get their water to the stick or the bucket up here to help fight fire from that air. According to 1901, must have a tank capacity of at least, for tenders, they must have a tank capacity of at least 1,000 gallons a minute. Primary use for these is to shuttle water from a hydrant to the fire ground if there's no hydrants around. And they provide at least 2 different ways of getting water to the thing. You got nursing, or you got using like dump tanks, like little swimming pools here. The best way to do it is to nurse, because you can use a pump and pump up the pressure to the truck, but if you got no water source, you just have to use the tank and do multiple trucks at once. Mini pumpers are like little pickup trucks. They're like pickup truck and they're a fire engine mix. They got special equipment and they also have fire equipment, but they're on a pickup chassis. They got to have at least a 500 gallon a minute pump and at least 500 gallons of water. They're mainly used to carry medical and extrication equipment, but they can also be a fire engine capability if needed. They have a full thing of hose. Like these ones right here, you have hose and pump, ladders, all on a pickup chassis. For pump locations, we have 3 different types. You got front mount, mid mount, rear mount. They're all pretty much what they say. The front mount is what sits at the front of the truck on the bumper, and they're mainly used for like wild van and pump and roll situations, but they're susceptible to damage when you're driving, and they're all right here in the front. You don't have to have it in drive to pump, you can pump and roll. Midship pumps are like your average fire engine that's in the middle. Some of them have a catwalk, some of them don't. They're ideal because if you have a catwalk, you can be the driver and see everything what's going on and not be out in traffic or be on the other side of the fire and you can't see anything that's going on, just having to keep walking and making sure everything is going right. They're the most common you find out there, and it's the preference of most departments. Rear-mounted pumps, they're commonly seen up north where your pump is protected from the cold in the winter months. The operator has limited visibility of the fire scene because you're in the back, depending on what side it is. It can be on the fire side or it can be on the side of traffic where you can't see anything and you got to watch out for traffic. Both the pump connections are exposed, so when you pull the hose off the back, you might hit one of these and break a connection. That's not common, but it's a possibility. So your jurisdiction or SOPs will dictate how you use that kind of engine. Pump panels, you got 2 different kind of pump panels. This is the analog, everything is open. You got to set your own governor, throttle, and you got all these gauges are separate. For your digital, it's all in here. The governor is in there. You don't got to do anything for it to. It'll fluctuate the RPM to keep the pressure at the same. So if you get more coming in, it'll go down so you don't overpressure the people on the line. When water flow, when we get a house fire and you got hydrants and you're the first engine there and you go by the hydrant, sometimes you'll catch the hydrant, start flowing water, and you'll have your water source to the attack engine. That's a forward leg, and this is how the water flows. It goes from the hydrant to the engine to the fire. In other situations, you got the hydrant's way down here, so the second engine has to come in and get the hydrant. They'll send water to their engine, and then go through their engine to the attack engine. And that's relay pumping with the same thing as a forward leg. The water just goes through another truck and more hose. When you put the truck in the pump, this person here, he'll show you how to do it. It's just a matter of throwing some switches and having the brake on and putting the truck in drive. Here's the PTO. This is the power transfer component. You gotta have the brake on to do it and put it in drive. When you do that, the truck will be good to pump. Those 2 lights have to be on for it to be pumping. If you only got 1 light, it won't pump correctly. And then this one, you can see the gauges up here. Once they put it in the pump and everything comes out right, you'll see the gauge go up to about 18. That says that the RPMs are reading off the pump. In this part of the video, we can't really see it, but you got a pressure governor here that's electronic. And when you do it, there's no sound, so you can't hear the truck revving and going down, but when you goes into the pump, you throw it in the pump right here. There's a tank, that gets tank water to the pump, and we're going to be using this deck gun to flow water. So he's going to use this to get the pressure up, and once the pressure gets enough to where we don't leak water out of the deck gun, he's going to flow water, which he's doing right now. There's the leaking and all that, because if you don't have enough pressure, you can't push the water all the way through without it coming out. up as it flows water. Can you imagine doing this on a fire ground when everything's hectic and you're having to pull stuff off the truck and maintain getting water to the truck? Because right now he's already at half tank and that's only been, what, 30 seconds? So once he opens the tank that pumps, his pressure is going to jump up because he's getting more pressure from the hydrant. So he's got to either the governor's going to RPM, put the RPMs down to keep the pressure the same, but you can also gate down if you can't get the pressure low enough. Which is, he's filling the tank now, which is what this is, because the tank's pretty empty right now. But these gauges are all separate gauges for the certain lines that are going out. Like, there's the water that we're flowing out the deck gun. But these gauges are all their own gauge. This is the master discharge of the electronic governor. When we're only flowing one, so this is the deck gun, it should match pretty close to the electronic governor, which it says 90 and this is pretty close to 90, so it matches up pretty good. And then that's the end of the presentation. If you have any questions, you can call me or email me, and I'll get you some more information, and we'll be able to go through this more on our shift. Thank you, and have a good day.